So last time we were together, we looked at things that looked like this. F of x equal a times the sine of x, or f of x equal a times the cosine of x, okay? Guys, the a in front tells me the what of this graph. What's the word for that?
How it's going to look.
No, there's a word for what it tells me. The number in front of that trig function. The A, that number.
How the amplitude.
The amplitude. A stands for amplitude, how high it goes from the x-axis, okay? Why don't we focus on this for now, okay? So, what is it?
There are these memes going around where Winnie the Pooh memes with a Y, and then it's Winnie the Pooh wearing a tuxedo and a top hat, and then F of X, because F of X is a fancier version of saying Y.
Okay. Okay. I'll think that maybe that had something to do with it, but let's move on, okay? So f of x, guys, I can't keep on, okay? You're gonna have to be quiet, or I'm gonna send you out of here, okay? We need to get through this. F of x equals sine of x. When we talked about the sine of x, it starts at 0. Where does it end? 0. Is that a surprise? No. What point? Those are the same points, okay? If you start here and you go all the way around the circle to 2 pi, you're at the same point. And if you keep traveling, what are you doing? You're hitting the same points time after time, okay? So that's why this graph, we're graphing one cycle of this graph. It's just going to keep on going, okay? So this sine function starts at 0, ends at 0. Halfway in between, it is at 0. Halfway between the first 2 points, where is it? 1. Halfway between the second 2 points is -1. And this is a curve, so you should have curves in your graph. And this is just going to keep on going as long as you want. But that is one complete cycle of the sine graph, okay? So if this graph starts right here at 0, when does it start to repeat? So when does it start to repeat itself? Not pi.
When it gets to 2 pi.
Yeah, so it goes up, it goes down. When it gets here, what do you think it's going to do? It goes up, it goes down. What do you think it does? Same thing. So it repeats itself after 2 pi. So once we reach 2 pi, this graph starts to repeat itself. Yes?
Oh, yeah.
Okay, well, you can just work on it, okay? We've got plenty of time to work on our drawings here. So let's look at the cosine function. When we graph the cosine, it starts at what?
1.
Okay, and therefore it's going to end at 1. Because those are the same points, 0 and 2 pi, okay? Halfway in between, it's what? Okay, and then halfway between those first 2 points is 0. Halfway between these 2 points is 0. Okay, again, this is a curve. If it helps to start drawing it out like a curve rather than a straight line, that's what this is. This is going to continue doing this same thing, okay? That's what this curve looks like. We only graphed it from 0 to 2 pi, okay? If I start at 0, when does it start to repeat itself?
2 pi.
When it gets to 2 pi, it starts to repeat itself all over again. So we'll say that it goes through one complete cycle in 2 pi radians. Now, let's look at another one. Before we do that, yesterday we would have graphed f of x equal 2 sine of x, right? How is this one different? Yeah, so this is not f of x equal 2 sine of x. This is a sine of 2x. So the way we graphed this one is we looked at, it starts at 0, it ends at 0, halfway in between is 0, and then it went up to where? Not 1. In this case, it goes up to 2. So this one went up to 2, and it went down to 2. So it did this, okay? Can someone take care of that?
Yeah.
Mm-hmm. Mm-hmm. Why don't we put our laptops down so we can focus on this, okay? 1, 2, 3, 4, 5, 6. I understand, but I'm looking at Carter. Eric.
It's a tablet.
Eric, why don't you put your laptop away, please? Okay.
Wait, there was an incident. Get him right. What is Robert Downey? This is
Okay.
theft of property.
Okay. Let's continue on. So, guys, we want to graph f of x equal the sine of 2x. Okay. So if x is 0, what is 2x? If x is pi over 4, what is 2 times pi over 4? What's 2 pi over 4? 2/4 is what? 1/2. Okay. What's 2 times pi over 2? It was not the trick question it's turning out to be. What is this one?
It's 1.
Pi. Okay. What is 2 times 3/4 pi? That's 6/4 pi. What's another word for another number for 6/4? Yeah. 3. We'll go with 3/2 pi. Okay.
That was Jake Landgraf, by the way.
Okay. For this one, let's see if we can do mental math in our head. What is pi times 2? Pi times 2 is?
Yeah, alright. 2 pi.
2 pi. Okay. So, over there on our unit circle, guys, on our unit circle, when I'm at 0, what is the y value? When I'm at pi over 2, what is the y value? 1. At pi, 0. 3/2 pi, -1. 2 pi, 0. So what I want to graph, I'm going to graph, here are my x values and my y values, okay? I'm graphing x and the sine of 2x. So these are my x values, these are my y values, okay? So I'm going to graph 0, 0. Okay, what's the next graph? Pi over 4, 1. That's right here. Pi over 2, 0. 3/4 pi, -1. And pi, 0. So again, the way to think about this graph starts at 0, it ends at 0 at pi. Right, so it starts at 0, it ends at pi. So it starts at 0, it ends at 0, halfway between and 0. Goes up to 1, down to -1. So this graph does this, okay? Now what it's going to continue doing is it's going to end up here again. So now if you look at this, how many revolutions or how many cycles of this graph did it go through from 0 to 2 pi? It went through 2 of them, okay? So what happened was, by graphing the sine of 2x, between 0 and 2 pi, it went through 2 of its complete cycles. Okay? So sine of x completes 1 cycle between 0 and 2 pi, and sine of 2x completes 2 cycles between there. So what we will say is, however long it takes to complete 1 cycle, so that's 1 cycle, and then you see it starts to repeat itself. Does the same thing. So this is 2 different cycles. So 1 complete cycle is what we call the period of this graph. So it's a graph that repeats periodically. So the period of this graph is pi. Okay. The period of this one is 2 pi because it takes from 0 to 2 pi to start repeating. This one has a period of pi. It starts repeating after pi radians. So what we will notice here is when we see graphs that look like this, a times the sine of bx, or a times the cosine of bx. The amplitude is always the absolute value of a, and the period is 2 pi divided by the absolute value of b. So whatever this number is in front of the x, 2 pi over that number, a positive number, is going to be the period of the graph. So let's look at these, and then we'll graph them in just a moment. So look at this example. What is the amplitude of the first one? We did that yesterday. Amplitude is 4. The period is going to be 2 pi divided by, and it's this number right here, that 4. So 2 pi divided by that. Now what's 2 pi divided by 4? Yeah, so this is just pi over 2. Okay? Carter. Yeah, let me keep that too. Okay. I understand. So, what's the amplitude of the next one? 3. The period is going to be 2 pi divided by the absolute value of negative 2. Okay. What is, this is 2 pi. This is 2 pi over 2. What is that number? That is pi. Okay. Okay. What is the amplitude of the next one? 6. What is the period? 2 pi divided by pi, which is 2. Okay. What is the amplitude of the next one? 1/2. How will I find the period? It's what? Let's don't make stuff up. 2 pi divided by 1/2. What is 2 pi divided by 1/2? It is 4 pi. If you can't do this in your head, guys, you got to write it out. Dividing by 1/2, dividing by a fraction is the same as multiplying by its reciprocal. What's the reciprocal of 1/2? 2 over 1. So what is 2 pi times 2 over 1? 4 pi. So if you're to graph this guy, it takes from 0 to 4 pi to go through one complete revolution. Carter, okay, I'm out of it. Okay, I'm sick of this. You're talking to Jack, okay? You're disrupting me. You're distracting me. Guys, I'm done, okay? Let's look at the next one. What is the amplitude? It's pi. What is the period? 2 pi, what? Divided by 1/4. What is 2 pi divided by 1/4? 8 pi. What's the amplitude of the next one? Amplitude is 4. The period is 2 pi over 6, which is just pi over 3 or 1/3 pi. And the last one here, amplitude, 1/2, period, 2 pi over 1/2, which is, 4 pi. So if you're graphing this, you've got to go all the way out to 4 pi before this graph starts to repeat itself. So we always want to be able to graph one complete cycle of the graph, okay? Now, let's look at how we're going to graph one of these guys. I want to graph 2 times the sine of 2x, okay? I know what this first 2 does. That's the what? That's the amplitude. That's going to tell me how tall the graph is, okay? And now let's look and see what the 2, this next 2 is going to do. That's going to tell me the period. So 2 pi divided by 2, that is my period. So what is the period of this graph? It is pi, okay? So that means I've got to go from 0 out to what to get a complete revolution? 0 to pi, okay? So you'll notice what happens in this section is I've stopped labeling the graphs because you're going to have to label these at this point. This is 0. Okay? The easiest way to do this is just to count 4 spaces. 1, 2, 3, 4, and write down pi. Why did I do that? That's the end of the period, okay? So from 0 to pi, this is going to go through 1 revolution from 0 to pi. What is exactly halfway between 0 and pi? Pi over 2. So I'm going to call this pi over 2. Okay. What's exactly between 0 and pi over 2? What happens when you cut this in half? That's pi over 4. Okay. So each of these is 1/4. So this is 1/4, 2/4. What is this? 3/4. Okay. So you completely label everything, and now we're ready to graph. So this function is a sine function. It starts at what? It ends at halfway in between. It is at 0. Okay. Now, normally this thing would go up to 1. What's it going to do now? Yeah, it's going to go up to 2. Normally here it would be going down 1, but it's going to do what? Yeah, it's going to go down 2. So this graph looks like this. Now, how is that different than the sine of x? What's different? Pardon me? Yeah, so the x is labeled differently because this tells me that 2 says to go out to 2 pi, you're going to get 2 revolutions. So if I went out to 2 pi, I would have 2 whole revolutions. So the period is pi. I just graphed 1 revolution. That happens between 0 and pi. Okay? So all the graphs are going to look the same. What's going to be different is how it's labeled here because of the period being different. Yeah, I would go out to 4 pi for the next one. Okay? So let's look and see what this guy is. So what is the amplitude of the next cosine graph? Amplitude is 1. The period is, it's 2 pi divided by 1/2, which is 4 pi. So that means I start here at 0. Count out how many spaces? 1, 2, 3, 4. And what is this point? 4 pi. Because it changes. Okay, you got to figure out the period. Okay? So if that's 4 pi, what's halfway between 0 pi and 4 pi? 2 pi. What's halfway between 0 and 2 pi? That's just pi. And this is 3 pi. This is a cosine function. What does a cosine start at? Starts at 1. What does it end at? 1. Halfway in between, it's where? -1. Halfway between those 2 points? 0, 0. So if it helps to make it sort of curvy, do it like this. You can see this is the cosine curve. So this is the cosine of 1/2 x. So these graphs all look the same. They're all the same shape. They're just going to be moving around. This is sort of stretched out. So if I only graph from 0 to 2 pi here, I wouldn't get very much of a graph. Okay, I wouldn't have a complete cycle. So I had to go out to 4 pi to get the complete cycle here. Okay, this next one. What is the amplitude? Amplitude is 2. What does that mean? This means this graph is going to go how high and how low? -2, okay? That's all it's going to do. So how do I figure out the period? The period is what? 2 pi divided by 1/3, which is 6 pi. Has this been reflected about the x-axis? Yes, that's what the negative in front of that does, okay? So this is 0. I'm going to count out 4 spaces. 1, 2, 3, 4. What am I going to call that? 6 pi. Okay. What's halfway between 0 pi and 6 pi? 3 pi, okay. And then what's half of 3? What is that? 1.5, so that's 3/2 pi. Okay. So this is adding, this is 1.5, this is 1.5. What happens when you add 1.5 to 3? 3 plus 1.5 is 4.5. 4.5 is another way of writing it, is just 9/2 pi. You could write this as 4.5 pi. Same thing. So this is a sine function. Sine functions always start at what? 0. Where do they end? What's in the middle? Okay. That's why I told you to try to remember that sort of talking point, because then you would know how to graph them when they change around. Now, normally the sine function goes up to 1. This one is reflected and has an amplitude of 2. What's the effect of multiplying -2 times 1? -2, okay? Normally this function would be at -1 right here. What is a -1 times a -2? +2. That is this right here. So what we see is this graph right here. Yeah, either way. But what's key here is you are having to label. I need to see what these points are, and I need to see where it's going on the y-axis. What are those points, okay? So look at this guy. What is the amplitude? Yeah, amplitude is 1. Has it been reflected about the x-axis? Yes. What is the period? To figure out the period, it's always what? 2 pi divided by 1/4. What's 2 pi divided by 1/4? That's 2 pi times 4, which is what? 8 pi. So now I'm ready to go to my graph. This is 0. I count out 4 spaces, and what is that going to be? Yeah, that is 8 pi. What is exactly in the middle between 0 and 8 pi? Yeah, 4. What's halfway between 0 and 4? 2 and 6. Okay. This is a cosine function. Where do cosine functions start? 1. What happens when the 1 gets multiplied by a -1? Yeah, so it's going to start at -1. If it starts at -1, where does it end? No. Same value, okay? Remember, these functions, they're a circle. So like wherever it starts, if it goes through a period, it's going to end at the same value, okay? So if this starts at -1 and ends at -1, the cosine normally, you're right, Leah, it normally ends at 1, but when the 1's multiplied by a negative, that made it -1. Normally, here in the middle, I'm at -1, but what happens when the -1 is multiplied by a -1? I go up to 1. So this is 1 and -1. So this graph does this. Okay. So that is one complete cycle of the negative cosine of 1/4 x. So you notice the graphs, they all look the same. It's just that the labeling of where it takes to go through one cycle is just different in each one. Amplitude. 3. Period. Period is pi because 2 pi divided by 2 is pi. Okay. Has this been reflected about the x-axis? Yes. So now it's just up to me to label the graph correctly. I start at 0. I count out 4 spaces. 1, 2, 3, 4. What is this? That is pi. What's halfway in the middle? Yeah, that's pi over 2. What's half of that? Yeah, that's pi over 4. So this is 1/4, 2/4. This is what? 3/4 pi. No, it's fine. You could write 1/4. It'd be the same if you wrote, 1/4 pi. That's the same thing. So normally the cosine function starts at 1. What's the effect of 1 being multiplied by a -3? Yeah, it's going to start at -3. Okay. Normally this thing would end at 1. What's the end result of that being multiplied by -3? It's going to end at -3. Normally halfway in between is at -1. What happens when -1 is multiplied by -3? Yeah, you get +3. So you're at 3 and negative 3. What happens halfway between these 2 points? I'm at 0. Halfway between the last 2 points, I'm also at 0. So this function is this. Okay. And one more. Amplitude. Amplitude is 2. Period. Yeah, so the period is always 2 pi divided by b, which is that number in front of x. So this is pi over 2. Is it reflected about the x-axis? No. So if this is 0, count out 4 spaces. 1, 2, 3, 4. What is this? Pi over 2. Okay. So what is 1/2 of that? Pi over 4. What's 1/2 of that? Pi over 8. So this is 1/8, 2/8. What is this? 3/8, and that's 4/8. Okay. So the sine function starts at what? Ends at halfway between. There we go. Normally it goes up to 1. Ours will go up where? 2. Okay. Normally it goes down to 1, but this one will go down to negative 2. So you see this graph right here. Okay. And that's all we're going to be doing in this unit. Every day we're going to be adding one new bell or whistle to this. Okay. So what we did yesterday was amplitude and reflection. Today we handled what does the period look like on a trig function. Okay. So next time I see you is on Tuesday. We'll talk about how these things get shifted vertically. Okay. And then we are not teaching on Experience the Arts Day. So that's Wednesday. This topic? Yeah, well, I mean, I had to cover radians before you, yeah.